everybody, and especially Björn Gambäck, who is our colleague at RISE and also at Norwegian University of Science and Technology. And the topic of today is hate speech in social media. The floor is yours, Björn.
Okay, thank you. Yeah, as Olof said, I work both at RISE and I've been at SIX before then and at RISE since 1989, but also since 2008. I'm professor in language technology at NTNU in Trondheim. In the last decade almost, I worked a lot on social media language, different types of language in social media in general, and different problems related to that. A lot of the work has actually been on hate speech or hateful and abusive language, you can say. Often the difference between what is offensive and what is hateful. So this is what I would talk about today. And first, just a few words about language processing in general, what we're doing here. Why am I in this seminar in the first place? When we talk about practical language processing, we need flexibility because language is evolving and language is different in different type of settings, as we will see. And the way to treat this flexibility comes from machine learning. So that's the main reason why I'm in this seminar, I can say, or why I've been working machine learning myself since 30 years back, basically. So when I say that I work in machine learning, I don't mean that I work on defining algorithms of machine learning, but I work on applying machine learning to language processing problems. And this is basically what I'm doing all along. As I said, in recent years, we looked mainly at social media language. The whole idea, though, here is that language is flexible, but it's not just totally flexible. We can't say anything at any time, but it's also predictable. And this is why we can apply machine learning. We can use prediction in learning algorithms. So, for example, if you have a sentence like, on the exam, I got A, and then you should try to fill in what can we fill in the blank with here. So we can guess that the person saying this probably is not going to say an A, because that would not match the article here. They could say football, which is, there's some probability, but there's a lot higher probability that they'll say B, D, C, or F in this case. But of course, it can be a lot of different things. And they got there's always a slight probability with any word in our vocabulary, but we can often predict with a lot higher probability that it's going to be one or a specific word. So if we say that the player scored A, we can probably predict that this is going to be a goal or a basket or a hoop or whatever, depending on wicket or which sport we're talking about, but probably they scored something there. So when we talk about machine learning on text, of course, in general, machine learning uses instances or examples of the data to try to fit a parameterized model. And of course, this is then used to make predictions about new instances. And of course, we have features that describe the instances in some ways that we can train the machines on. When we talk about text analysis, the instances are defined as documents, basically. And documents is sort of not what the layman would call a document, but in text analysis, basically talk about documents as anything that is the level we make the analysis on. So it doesn't matter what the size is. A document can be a book, can be a tweet, it can just be a single sentence, a chat message, etc. And then, of course, the features, when we talk about text analysis again, there are different aspects of the text that are relevant to this task. And all the features then take values, which are the realization of the feature in specific text. So we can say that when we talk about machine learning for natural language processing, we basically, if we talk about supervised learning, I should say, we have two different sets of applications of the systems. So we have a training phase and a prediction phase. And in the training phase, if we have a supervised learning, we of course have input data together with labels. We try to extract different features from the input. So we use some feature extractor to do that. We have the features with their relevant values and train a machine learning algorithm on that to build a classify model. And then in the prediction step, again, we take the same input, we use the same type of feature extractor, the same type of features, and then we apply the classifier model to try to induce the label from the unlabeled data. So again, language basically requires flexibility, and this we get from machine learning algorithms. So what are features then? They can be in a lot of different levels. I will mainly talk about features that are on the word or the character level here. But they can also be on the document level. It can be also metadata which are related to different documents. And of course, it can also be data that is related to the user or different types of users, as we will also see. But traditionally, people have looked at word spaces and the main features. So we can, for example, look at what is contained inside the word, what is the lemma, the main information source, and also then prefixes and suffixes, etc. And we can try to get rid of words that are commonly occurring or have no distinguishing value or discriminative power, you can say, in a specific context. In recent years, people looked a lot more about processing on the character level, actually. So we look at features inside the words. For example, then subsequences, bigrams or trigrams of characters. And deep learners tend to look at a lot of the character level, actually. But we can also look at characteristics in general, if they're capitalization, what kind of part of speech sequences or word sequences are there, etc. Or then go up at a high level, look at the grammatical structures or group words with similar meanings, look at the semantics. And now the main problem, we say that in language processing, and the main reason why we need this kind of flexibility and we need machine learning is that formal languages, the sort of the traditional programming languages, etc., and also like formal languages in chemistry, they are pretty strict. They should follow the rules, and they don't change. The rules don't change basically, and often they are application specific. While natural languages, they are flexible. They're evolving all the time. They're changing depending on what time point we are in, who is talking, who they're talking to, etc. And they are basically normally non-specific to the specific application or some domain. The two main characteristics of languages that use a lot of redundancy and a lot of ambiguity. Maybe you didn't think about this so straightforward, but basically every word, every sentence contains enormous amounts of ambiguity, actually. And we compensate a bit for that by introducing redundancy. And normally we talk about formal languages, we try to avoid ambiguity and also try to avoid redundancy. To make things worse, if you talk about social media language, for example, Twitter, I will use Twitter as an example here because a lot of the work that has been done on social media language has focused on Twitter because Twitter is an easily available resource. Should say that the language on Twitter is a lot more formal than the language in some other type of social media settings, like in chat rooms, for example. So sometimes Twitter is a bit between the formal language and the really informal languages. But the main point when we talk about social media languages in the first bullet point here, namely that people write a lot more as they speak. So social media language is often more related to the spoken language than to the written language, or is in some intermediate form at least. And of course, we see a lot of specifics in social media language. People use a lot of abbreviations, and this is in particular on Twitter then, because of the restrictions on the length of the tweets. but they also use things like elongated words, like so, etc. Add a lot of vowels just to stress a point or something. And of course, we use a lot of emoticons, emojis, which can be seen as some kind of language in itself. But then there's also a lot of specifics to the different type of social media platforms, like retweets, hash marks, also hyperlinks, images maybe, and often a lot of spam, etc. That we might find as well. So, for example, if you want to try to identify the language in social media, say that language identification, if you look at the formal text and try to identify the language, this has been claimed to be basically a solved problem. But if you start to try to identify language on social media, this is very far from a solved problem. Because then, of course, the non-standard language and the stuff I had on the previous picture, but also people have a lot of spelling errors, a lot of grammatical errors. And also, if you look at different languages, maybe people write in a language which uses a different character format than the Latin alphabet. They might still use the Latin fonts, but do some kind of phonetic typing, or they might mix languages. And this is very common. It's called code switching or code mixing. We have several different languages, maybe in the same message, maybe even in the same sentence, and actually even inside the same word sometimes. So what can we do about this? And what can we do and try to look at detecting abusive language then? And why do we want to try to do this? The main problem for all these type of social media platforms is that people post a lot of abuse all the time. I don't know if you saw that after the European Championship final, 3 of the English players missed their penalty kicks. And the Guardian right away afterwards, they identified 2,500 tweets that were racial abusive against those 3 players, since they happened to be colored, all of them. So 2,500 tweets, just I think was within the first half hour or something like this. It was very, very soon after. So there's a large amount of online abuse reported every day. And of course, the social media platforms, they try to do something about it. And they try to remove the abusive language. And they try to remove the posters of the abusive language. But it's basically impossible for the human moderators to keep up with this. And the worse, if you put humans to try to take care of this, the abusive language, there is a real problem for those persons who have to face the abuse themselves and see what kind of messages actually are out there. There have been a lot of stories about the moderators basically breaking down themselves. They can't tell their families about what kind of nasty stuff they have to work with every day. So there's sort of no outlet for them, basically. So often then you can't work as a moderator for quite such a long time because you get worn out. And then, of course, abusive language in itself. There are a lot of different types of abusive language here. There's cyberbullying, where they attack a single person, trolling, where people often sort of the trolls trying to amuse themselves rather than necessarily have an evil way in itself. And the goals are not necessarily evil, but the result is normally evil for the persons that are abused. And of course, there's the proper hate speech, racism, sexism, etc. There's also the really extremist language where things are getting dangerous, and people trying to get people, involve other people in extremist activities, etc. But there's also sort of the nicer form, the offensive language, still contains maybe profanities, insults, and abuse. And there's often a very thin line between, for example, hate speech and offensive language. Which, if you look at Twitter, you might see that you have a tweet and then there's some replies to that tweet, and then Twitter says, we have included the first something replies. And if you want to see the ones that also include abusive language, you have to click on this link or something. So you don't sort of per default get to see the abusive ones that they have identified. And that tends to work a bit so and so. So quite often you get abusive tweets or replies anyhow. And then if you click at those that Twitter have identified as abusive, you can't figure out why they did that in the first place. So this is still a very difficult problem. So what people normally try to do is try to look at the restricted subsets of abusive language. So people have often looked at only one specific data set or one specific task or domain, or data which has been annotated in one very specific way. And of course, there are a lot of other things we need to address. As soon as there is a good method to identify hate speech or abusive language, the people are writing this kind of stuff, and they come up with adversarial methods to try to bypass this detection. A common would be if we have identified that ASS would be an offensive word, people would write a $, which would still look the same, but would not be identified right away as the same word by a simple algorithm and so on, at least. If you look at hate speech, you will see that, for example, right-wing extremist groups, they will not write about, they will not use terms like Hispanics or Jews, etc., or blacks when they talk about different groups. They will use very specific terms that are known often only to them, and those terms will change all the time. So if you write a system that is set to identify these terms, then they will not be the same next week. Another issue, of course, is if something is abusive in itself, or if it's abusive together with something else. So you have images, videos, etc. Maybe the text doesn't seem to be abusive, but it is together with a GIF or a meme, and it shows something, and together they form an abusive content. So we can also include here a lot of metadata information. We can see that the user who writes something or the user they are addressing can make this abusive. Or we can look at a lot of information we try to identify abusive language. Again, then when it has been written, where it has been written, what kind of network the user had, who are their followers, who do they follow, etc. All that type of information can give us additional data we can use to identify the abuse. And I said that a lot of people have looked at just seeing specific data sets. And the reason for that is there is no sort of standard data set for hate speech. And there are a lot of data sets out there, but people tend to look at the only one specific data set and then not look at cross data set identification. But how do they get this data in the first place? And well, you can first look at who has been annotating. So who were the annotators? Were they experts in identifying hate speech, or did they use some kind of crowdsourcing service like Amazon Mechanical Turk or Crowdflower, where basically we pay people a very small sum of money to annotate a large amount of data. And then, of course, the people who do this annotation are not necessarily experts. A lot of hate speech or offensive language identification can also be that we look at what moderators in different platforms have actually been removing, but then we don't know why they removed something. So they can have removed something just because it was not fitting to the platform's policy itself, because the moderators would rarely mark why they removed something. Also, when we look at abusive data, we can look at what type of annotation we try to say. I said that one problem is it offensive or is it non-offensive? But we can then sort of build up a hierarchy here. So if it is offensive, is it directed at somebody or a group, or is it just sort of offensive in general? If it is directed at somebody, is it directed at a specific individual, or is it directed at a group? Or is it directed at something else, like an organization, for example? And then, additionally, then, of course, who is the author? That can give us quite a lot of information. There's one big data set of abusive language got a lot of criticism afterwards because they used Crowdflower, I believe, to annotate the data. And the annotators saw a lot of language containing things like nigger, etc., and assumed right away that this was abusive language. But they didn't know that this was written by a small group of colored authors to a colored audience. So this is more used as greeting phrases, but of course still offensive greeting phrases, but it was annotated as hate speech when it should rather probably have been annotated as offensive. So if you don't know the author and you don't know who it's targeted at, you might think that this is stronger than it is, or you might not understand that it is as strong as it is either. So it works both ways. So in this case, and if you contain the N-word, is it always racistic? Or is it racistic even if it's written in African American vernacular English, will be the formal term. And as I said, of course, we can use a lot more metadata or information which is outside of the language at least. So we can look at the community, and community, probably a term that you've heard before, but formally we can say that this is a group of people that possess similar characteristics. So they're homophile in that they are forming a group in the sense. We can look at how this community is formed. For example, then by followers and followings, as I mentioned before, but also things like if we are liking or retweeting something. And then we can look at the users. What kind of personalities do they have? Or do they have real life relations to some of the followers, etc.? How do they behave? Do they follow? What kind of social values and social ethics do they follow? So that we can identify this, and from that we can extract information that can be useful when we try to identify the hate speech. Unfortunately, getting a lot of this data is quite hard. So, for example, on Twitter, it's possible for the users to say that I am this and that age, I come from this country, or I sit in that city, etc. But of course, some people will lie about this. Some people will actually tell the truth, but the truth will change. So they are in one country and then they move to another, or they come from one country and they're posting in another country, and then they identify themselves as being from the country when they're posting in, or if they identify themselves as being from the country they are originally from, etc. And of course, if we're talking about hate speech or extremist language, etc., it's very rare that the users give out this kind of information. So it's often missing in social media. And like I said, even if it is available, it might not be trustworthy. People will say that they are situated in Antarctica, and we know that this is probably not true. But if they say that they're situated in the say, well, the British Virgin Islands or something like this, or Cayman Islands or something. It might be true, but maybe they just choose something which happened to come up on a list. So we actually carried out some experiments looking at the effects of user features and what effects they have on Twitter hate speech detection. So what we tried to do was try to see if information related to the users can be helpful at all in identifying online hate speech. To do that, we looked at 3 different data sets from 3 different languages. And as you can see, they're all small here. And the German data set is just 170 users. And only about, well, 2/3 of those are identified as being hateful, etc. There's also a data set in Portuguese and a bit larger data set in English, but still also the English data set is quite small. The reason why we used this for this study was that this English data set has been used. I said there is no benchmark data set in hate speech, but this was one of the very first ones created. So it's been used a lot. So it's a useful comparison. And the same actually for the German data set, even though it's so small. And the Portuguese group, they've done a lot of work on hate speech, such. I only report the main findings on the English data here. So we could see that the gender distribution basically for all the tweets, there was a bit more men than women. And the largest group is then unidentified here. We couldn't use if there were men or women writing actually from their metadata. Say. And if we look at the hate speech, we see that the larger part of the hate speech was written by men, but it's basically the same quote as the men versus women quote overall. Which then it has been claimed before that men write more hateful online. But if you actually look at this data set, at least this is not confirmed in the data. So what we did actually, we looked at taking tweets and extracting information from them itself, and then just used a logistic regression hate speech classifier as a baseline. And then we added features like the gender, but also the network, friends and followers, the activity, how much they're posting, and what time they're posting, and also if you could get geolocation or more information about their profile, so we can see that if somebody's using a default profile or actually changed their profile, or they're using a default image or changed the image, or if they have made their lists public or not. And that kind of information is also available. So if we try to do hate speech detection on this, we can see that if you only look at the textual features, you see that quite a small portion of the hate speech was actually identified. While if we add the user features, a lot larger portion of the hate speech was identified. You can also see that the data which should have been identified as non-hate speech, some more of that was actually identified as hate speech now. So there are also a lot of other challenges here. This is a short story about another problem. This guy, Paul Chambers, he wrote a tweet about the Robin Hood Airport in Sheffield, which was closed because of snow. And he wrote, Robin Hood Airport is closed. You got a week and a bit to get your together. Otherwise, I'm blowing the airport sky high. Now, is that an offensive tweet? well, it contains some offensive language at least, is that a violent tweet. It contains a threat. I'm going to blow the airport sky high. What happened was that MI6, I guess, came knocking at Poor Chamber's door. They had identified a tweet about an extremist attack or terrorist threat to an airport. So they arrested the guy because their system did not identify that quite certainly this guy was sarcastic. He was just upset that the airport was closed because of snow. He had no intention of bombing the airport. So identifying if something is sarcastic or if we're using metaphor, etc., then that's another problem then. So in general, what we try to do is, of course, build a language model. We try to build statistical models of word sequences and use those to establish the probability of a word sequence occurring. And then this probability distribution depends on the data. It depends on the size of the data, but also the type of the data, the domain we get it from, etc. So if we talk about a specific language model, we can talk about specific properties it can have. But those properties will not rely on pre-compiled knowledge. And this is an important part. We can use the data itself to make statistical calculations or machine learning algorithms. So in itself, building these language models should not rely on or much supervision at least. And the whole idea is that I talked about that language is evolving over time. So we build language models of the language. We should be flexible to the change. So if we get new data, we should be able to change these language models. Of course, we need to make sure that the data we get is also relevant to a specific domain. And when we talk about language, I say that it's very, very difficult to identify if something is abusive or not. It's difficult to identify what somebody means in a specific context because, again, the language changes and it changes fluidly. It's often called the semantic drift. That's something which meant something in one day, a week later, or 10 years later at least, or 100 years later, it means something different. Or it means something different depending on who is saying it again. So I mentioned that we talk about text corpora, so text collections. And basically we can collect textual data and use it as a language model. And in general, we talk about annotated or not annotated data. So often we talk about tagged corpora or not tagged corpora or untagged. And the basic problems we face here that both the data is sparse and that it contains unknown words. And of course, that contain words that are used in ways that we don't expect. So a corpus in itself is basically just a collection of documents. It can be the raw text, but as I said, we can also add other information like metadata, so the title, the author, the data, language. If we talk about annotated text, we can add information like the part of speech, if something is a name or not, what kind of language should we identify this, where things are referring, sentiment if something is positive or negative, etc. But if we try to collect this kind of data, how do we ensure that it actually represents the task we look at? So what in general is a good way to assure that the document or the corpus, the resource that we're trying to build is actually available and useful for others. And again, then how do we annotate it? How do we say that something is, for example, abusive or not? Another issue when we can talk about annotation is what level do we annotate? Do we annotate, for example, the entire tweets? Or do we annotate the words in themselves? Are they abusive? Or do we look at annotating information like a semantic level or a lower level or on the character level, for example? And of course, how do we mark this in different ways? And Another type of meta information we can look at is the personality of the user. And this is something we actually investigated quite a lot. But to investigate the personality, it's not so easy. There are some resources available that says that, okay, if people are using this type of words, they are positive, or if they're using this type of words, they have specific personality. And for example, a group of psycholinguists in Texas, Pennebaker et al., they created something called LUC, Linguistic Inquiring Word Count, which is basically a lexicon. It says that all these words have some specific, carry some specific emotions, basically. There's also similar lexicon from NRC Canada, National Research Center Canada. It's called EMLX, which also says things about emotions. There's a tool called the Harvard General Inquirer, which has been built since the 60s, actually. We also try to say if words are positive or negative in some way, and also what kind of feeling different words induce. And there are some other, like the MRC Psycholinguistic Database from the UK, the Medical Research Council, etc. But what we try to do is investigate this kind of language or this kind of personality models and say, so what kind of personalities are the ones that spread out cyber hate? Do their social values affect this? And is some specific personality type related to some specific type of hate speech, for example? And when we looked at several different personality models, and one is called the most common one, you say, it's called the Big Five model. It's also called the five-factor model or the FFM model or something, the ocean model, because of the five personalities that identify. So openness, cautiousness, extrovertness, agreeability, and neuroticness. And when we try to look at this type of personality model, introduce it based on data about personalities. But we also try to look at a specific part of it, namely what's often called the dark triad. The sort of the darker sides of the personality, namely narcissism, Machiavellianism, and psychopathy. So if you can identify those and see how they are reflected in hate speech. And finally, we also looked at the values, the social values and the ethics. And there's a model by an Israeli researcher named Schwartz. It's called the Schwartz Values and Ethics Model, which has been used by him and his disciples quite a lot to annotate personalities from all over the world, basically, into 10 different types of values and ethics, basically. And in the five-factor model, the five personalities are basically assumed to be the five personalities that people normally carry, while the Schwartz model, these different categories overlap a bit, and you can have several of them. Normally you will have several of them, but it's a different extent. Now, if you look at sort of the modern classification or modern text-based classifiers, we say we use transfer learning a bit, or quite a lot, and I just briefly address what we've done there so far. So the idea transfer learning space is that we have a general model which we trained on general data, and we have domain-specific data. We can train a more domain-specific model. So we transfer learning from one domain to another, basically. And the state-of-the-art classifiers in language processing are based on this transfer learning ideas. They use attention-based mechanisms, what's called transformers. And the most common, the one which has sort of the first breakthrough is called BERT, bidirectional encoded representations from transformer from Google. And then there are a lot of versions of that. We used Albert, for example, quite a lot, since the light portion of this contains fewer parameters. A lot of people look at, if we want to do language processing on tweets, again, social media language is specific. Several different research groups are trained BERT portions on tweets. So there is something called BERT tweet. There's another one called tweet BERT, etc. Trained social media language in general. And of course, there are models trained on different languages. The ri.se has to go with the Swedish National Library, worked on training this type of language models for Swedish, and also together the Norwegian National Library and the Språkrådet try to build a BERT for Norwegian, etc. And there are basically BERT for well, for a lot of the major languages, you could say. Last year, Baidu came up with a similar language model or a framework called ri. It's called Enhanced Representation Through Knowledge Integration. So a very pushed for abbreviation, but of course it's related to the Sesame Street. Everything is Sesame Street related. We also looked at so we looked at both BERT, Albert, and ri, but also methods like GANs, generative adversarial networks, and ensembles of these different types of methods. So I've just concluded some of the work there, and in particular we looked at the problem between to identify hate speech versus offensive language. So it's quite difficult, as I mentioned at the start of the talk, how do we say if something is offensive but non-hateful, or if it really is hateful? So to do that, we looked at 4 different types of deep learners, all based on the BERT architecture then. So 2 of them were pre-trained on general language data, and 2 were further trained on unlabeled domain data. So the idea then would be that what we were hoping was that these further trained domain-specific models would help us when we transfer knowledge from the general language models. Then, as I said, there are quite a few data sets of hateful language, but there are very few that make this distinction between hateful and offensive language, actually. So we looked at 2 specific data sets by Davis et al. And Font et al. And then this Davidson data set, it contains roughly 25,000 tweets, and the Font et al. Data set is started up by about 100,000 tweets, but the ones that actually were useful are something like 80,000. But the Font data set, they also said that what we annotate can be quite important. So Davison's data set, they annotated normal, offensive, and hateful language for Font et al. They also annotated spam. So about 10,000 of the tweets were actually spam. So to be able to compare these 2 data sets, you have to remove that part of the data. I should say that one of the main problems when we talk about data sets for something like abusive or offensive language on the tweets is that this, like Davison or Font et al., they have annotated their data set, but they're normally you're not allowed to spread the tweets themselves. If you annotate something from Twitter, you're allowed to work on the tweets, but you sign with Twitter an agreement that you're not allowed to give away the tweets to somebody else. So what you can do is you can annotate the tweets, but you cannot annotate the text itself, but the tweet ID, which is an identifier saying what the tweet, when and by whom the tweet was written, etc. So the tweet IDs are unique, and you can assign your annotation to that. But when somebody else tries to use this dataset later on, it might be that this tweet that was annotated is no longer available from Twitter. And since the group is doing the annotation, are not allowed to spread their annotated textual data on, anybody who wants to do new research on the data has to download the tweets from Twitter. And of course, if we talk about hate speech, Twitter will have tried to remove the hate speech. So a lot of these tweets might have been removed. They might have been removed by the users themselves, so the users might have deleted themselves, of course, or Twitter might have stopped the users. So this the data sets that I list here are the ones that were accessible to us when we looked at the annotations a couple of years after they were annotated by the groups. I should say now that the Davidson et al. Group, they tried to circumvent the Twitter agreement by actually releasing the tweets, the text of the tweets, but not the tweets themselves instead. So you don't know that, you don't have the metadata information, but you have the actual texts. Most groups would only release the tweet IDs and the annotation, which Untitled all did then. But to be able to use this kind of social media data, we need to do a lot of cleaning. So we need to remove stuff like retweets, URLs, numbers, mentions. A reason to remove a lot of numbers, and also there are a lot of numbers in tweets that are indications that they are spam actually, and that spammers tend to resend the same tweet, but just with a number, a counter. And there are also a lot of tweets that contain things like the degree symbol, rather than just tweets about the weather. And those types of tweets can also be removed right away. But also in this case, we want to remove mentions and retweets, etc. And then we try to normalize the data. For example, put it all into lowercase, etc., which can remove, of course, some of the information, but gives us a smaller, similar data to work with. So the BERT model architecture basically looks like this. There is input representation. There is an encoder stack, which is the BERT model itself. And on top of that, when you try to do make an application, you train your own classifier on top of whatever comes out from BERT, basically. And BERT itself comes in several different versions, called base or large, etc. And those also are pre-trained on both case data, so where you make a distinction between upper and lower case, or uncase data. So we used two of those, the smaller BERT base and the larger BERT large, but also only the uncase versions. And then on top we added a simple feed-forward network, which one input layer, one hidden layer, one output layer, and a softmax is laid to produce the final class label. And as I said, we also tried to going further and training into new BERT models on domain-specific, adding unannotated domain-specific data. So to do that, we only require raw text, so not the annotated text. But we have two tasks here. We need to do next sentence prediction and what's called a masked language modeling. And mask means that we mask out some of the words in the input data. So we trained two new language models using both, so the BERT models themselves are trained on Wikipedia and then book corpus to a specific checkpoint. And from that checkpoint, you can further train a new model. And we collected a lot of data from other sources. People have annotated hate speech, but we removed annotations and just used the raw data, and then got to something like 170,000 tweets. Then we run experiments on this, and we can see that if you compare the BERT base, the BERT large, and the BERT base from the further training and the BERT large further training, there's the first BERT large actually got the best macro average. But you can see that the results overall are fairly similar. You can also note that basically all models have problems with the hateful class, and the worst was the BERT base, the further trained, which only got an F1 score of 0.3 basically. The same models trained on the font at all dataset, which was about 4 times larger than. Again, you can see that the values are fairly similar for all models. This time the BERT base model was the best overall, but again, then all values are fairly similar. The BERT large, which further trained, overall got the best precision, and the best recall got by BERT large, which was not further trained. And again, all models struggle on the hateful class. They're a little bit better here, but not that much better. Basically, they got an F score of 0.4 instead of 0.3, which is still not useful. Right? So what are the problems then? So we just look at the BERT large model here. What the BERT large model predict compared to what it should have given. We can see that in the confusion matrix, it's fairly good on the diagonal, but the main problems here are, for example, it classifies things that are hateful as only offensive quite a lot, actually more than what it classifies hateful as being hateful. And in general, you see there are a lot of mistakes here on the hateful class. When it looks, we look at the font at all dataset, it even classify more hateful language as normal than it classifies as hateful or offensive. So we can see that overall that it's very difficult to distinguish offensive versus the hateful language. And what we can call slurs then are often predicted as hateful. And this is related to what the annotators also have been doing, that the annotator often, if something contains curses, the annotator as hateful way too often, basically. So here we see this kind of problem that offensive language is classified as hateful and hateful language is classified as offensive. And then it might actually be that some of these are actually proper annotation errors, because there are actually some tweets that are categorized by more than one annotator, and some of them are annotated as hateful and some are annotated as offensive in almost exactly the same tweet, actually. So that also shows that things are quite difficult. So just a brief comparison to the state of the art then. If you look at the BERT large on the Davidson et al., the work done by Davidson et al. Themselves, then the work done by Font et al., we got fairly similar results to the original ones on their own on the Davidson dataset. And the work by Gishaga et al., they got a little bit better on using a transformed word embedding model, which is some improvement. Looking at the Font et al. Dataset containing the spam class, there's not so much to compare to, but work by Lee et al., they compared both using convolutional networks and recurrent neural networks. And there we can see that the BERT base actually outperformed those systems. They outperformed the CNN quite clearly, but got just in a margin of error better than the BERT large model and the Lee et al.'s RNN model. So the Font et al. Model, if we remove the spam class, we see that actually the BERT base, if you compare it to some sort of standard machine learners, see that it outperforms an naive base, which is not a surprise, but it slightly outperforms the support vector machines in logistic regression, but not by being margin. Again, it was best on the hateful class. So the bottom line then is to form knowledge from the pre-trained language model gives models that are better at distinguishing abusive language nuances, you could say, but not by a big margin. So we couldn't see any further improvement using the further trained language models at all. But at least we reached state-of-the-art F1 scores are slightly better than the state-of-the-art, basically on all the problems here. And that these BERT models overall are a bit better at separating offensive and online language than the compared solutions. So this was basically what I planned to say today. I should say that I didn't talk more about this personality models, the work we've done there, because there wasn't much time, but we have written this up in a couple of papers around this slide. And we also looked a lot more at the problem of different data sets. It's also been reported in other papers. So any questions?
Perhaps I can start with a question.
Sure.
So in these data sets that you've looked in, what is the inter-annotator agreement there? You talked a bit about the difficulty of annotating this. Are there any numbers for that?
Yeah, I don't have them on the top of my head, but I think normally you see that there's something like 70% or something, but the main problem is often not the inter-annotator agreement within one data set, but between different data sets, because what you annotate as hateful, when one group annotates as hateful is not what another group annotates as hateful. So the instructions that they give to the annotators is often more of a problem than the actual annotation.
So internally in the dataset, you think there is not much confusion between, for example, the hateful class and the offensive class, which was the difficulty for the classifier.
Yeah. So in this slide, you see that what Davidson et al., for example, did on their own data set when they built classifiers. Of course, you would expect them to get really good results, but they're in the low 90s basically, and that's basically where the state of the art is. And one of the problems then is that you have to use the majority class classifiers, but they haven't removed some of the problematic tweets. And this is what I mentioned, that there are some annotation errors in the data. Of course, there are annotation errors in the ways that the annotators simply didn't agree, but there are annotation errors that are very obvious, that they have annotated the same tweet in different ways. So we can identify that this is exactly the same text, but it has different annotations.
So Jesper has a question.
Yeah, I had a couple of questions actually, but one is a continuation actually on your question on inter-annotator agreement was, or at least peripherally related. So one thing was, do you know if there is actually any distributional or concept drift within each data set? And if the annotator agreement stays kind of equal over the full data set inside the same data set, obviously, but or if there is a drift compared to beginning versus the end of it. And also related to that, when you trained your models, I assume you just did shuffling and a split and not trained it sequentially, or?
Yeah, we ran temporal cross validation, and so that's a shuffling and split if you want. But I don't think there was any drift, say, inside the data sets while they were being annotated, if that was your question. But of course, there's a drift afterwards. So what is offensive not changes over time. So these data sets are from, I think, 2017 and 2018. So already there we can see change. but I mentioned that there was a problem with one data set, that what was annotated as hateful by the annotators was not necessarily hateful if you knew who had been writing it. So actually this Davison data set was the one that has been analyzed later by another research group. And then they basically said that if you look at this later on and you see that, okay, the authors of the text were not what the annotators had the information about, then maybe the annotation should have been different. So that's sort of that's a kind of semantic drift, because it depends on the social setting of who the authors are.
Yeah, yeah. Okay, so if nobody else has a question, I can ask another one, maybe.
Sure.
Also just a continuation, like you said, depending on the author, were there any consideration in terms of bias? I mean, it's a pretty large discussion in the wider machine learning community in terms of using gender or race, for instance, to classify things. So in this case, I mean, it's not unconceivable to think of situations where you could have a biased model saying that just because you're a man or because you happen to have a certain friend, you are more likely to be flagged as a hate speech person.
Yeah, and that was actually one of the problems I talked a little bit about when I said that when we tried to look at the user data, people previously had claimed that men were more likely to write hateful stuff on the net, for example. And we couldn't see that when we actually analyzed the data. That was the data set we analyzed, and the original authors of that data set had made this claim. But then this was actually not in the data if you looked at it. So that type of bias or using that kind of information can be dangerous in itself. And in particular, since we don't know, it's not very easy to deduce it from this kind of demographic data from the data, from tweets, for example, because of course people can lie about their personality, or they can lie about who they are, they can lie about where they are, etc. There have been some studies that basically say that people tend to be quite truthful when they talk about their personalities online, actually, that the online personalities reflect a lot of the offline personality, if you want, the real life personality. However, when we talk about hate speech, I would not make that kind of assumption, because the hateful authors tend to hide their personalities, or their personas at least. But we can look at this kind of network information, and that turns out to be quite useful. You can see that people that follow, not that many, but have a large number of followers, that can be an indication of somebody who's posting hateful stuff, actually. Of course, it's not just because somebody has a lot of followers doesn't mean that they're posting hate stuff. But that can be one indicator, at least, that can add to some of the flags.
But I guess the ethical discussion is not whether there actually exists a correlation or not, or the discussion is rather, should we use it, even if there exists one?
Well, I think one of the points of the ethical discussion is that we can't even be sure if it really exists, or if it, at least if it gives enough information that can be trustworthy. But of course, another thing is if you can use personal information at all on if you do any processing. There is when I talk about inducing personality on the web, there's a lot of people, including us, have used the My Personality dataset, which was collected by a group, originally a group from Cambridge. It has gotten a lot of bad rap because it has been used, for example, in the previous US election and in the Brexit referendum, etc., for directed commercials for different user groups. But that is also the only large-scale personality data set which is available basically. So should you use that or not? That's really an ethical question. But you obviously have to include that kind of information very, very carefully in your work.
Yeah, I was just curious if that was a conversation that you or others in this field have had, but it sounds like it's
very much indeed. But when we looked at the personality or the characteristics of the hate speech posters, we looked at a lot of this type of information about personalities and how you can induce personalities. But of course, there is both the problem with, that you can't really do that with in a high probability, or it's not statistically true. Of course, when you discuss personalities at all, what is a personality and how can we deduce that itself? And of course, what kind of information can we use to really classify somebody as a hate speech poster, or even worse, if you look at if somebody is an extremist, etc. If you look at this example, the guy who posted a sarcastic tweet and was identified as probably being a terrorist, and he got arrested actually and had to spend a night in jail before they realized this was not the case. Okay. In that case, should MI6 or whoever it was who made this decision, should they have been using this kind of information right away? Or should they use more information to not arrest the guy?
Yeah. All right, thank you.
Do we have any other last question for Björn? Otherwise, thank you, Björn. And next week we have Anders Holst, who's going to give a talk. So welcome back next week.
Yeah, thank you all for listening, and thank you, Olaf, for organizing this.